All right, so we're going to talk about Pascal's triangle a little bit. And here's what Pascal's triangle looks like. And I would never have you just create this completely from scratch, but if some of these little honeycombs here were blank, you could easily fill them in. So if you take a look at it, 1 plus 1 will give you 2. 1 plus 3 will give you 4. 10 plus 5 will give you 15. So any two adjacent to each other will add up and give you whatever is the one underneath it. So 8 plus 28 is 36, and so on and so forth. And the way that you can use this is you can expand a binomial. So for instance, this very first one could be used to expand x plus y to the 0. Well, x plus y to the 0 is just 1, so there's your 1. The second one down could be x plus y square to the first power. That would just give you x plus y. This next one would give you x plus y squared. So that would give you x squared plus 2xy plus y squared, and so on and so forth. The next one down would be for a cube, a quartic, and so on and so forth. So let's take a look to see how we can actually use this. All right, so here's an example. I have 2x plus 3y to the third, and I'm going to actually call A, I'm going to call 2x, and B, I'm going to call 3y. So first I'm going to expand A plus B to the third. Well, if you remember from our Pascal's triangle, this here is my third power, so my coefficients would be 1, 3, 3, 1. So if we take a look at this, my coefficients here are 1, 3, 3, 1. So now I've expanded it. I start with a to the third. My a's are going to go down as far as their exponents go. So I have a to the third, a squared, a, and my b's will go up. So there's no b here, there's a b here, b squared, and b to the third. Now that I've expanded that, I'm going to go ahead and substitute in everywhere I see an a, I'm going to put 2x, and everywhere I see a b, I'm going to put 3y. So I have an a to the third, so a is really 2x, so I'm going to put 2x, and I'm going to raise that to the third power. To that, I'm going to add 3. Well, I have an a here, so I'm going to put 2x. This will be 2x, and I'm going to have to square that. And then I have b, which is 3y. Plus, I have a 3. I have now an a, so that'll be 2x. And I have a b squared, so that'll be 3y squared. 3y, the whole quantity squared, plus b to the third, which will be 3y to the third. All right, now that I've written it all out, I can just go ahead and do all of the math. Well, 2x to the third, I have to raise not only the x to the third, but the 2. So this will be 8x to the third. Well, here I have to use my PEMDAS rule, so I have to do my exponents first. So 2 squared is 4. 3 times 3 is 9. So 9 times 4 would be 36. So I'm going to say plus 36. And here I'm going to have an x squared and then a y. Plus, well, let's see. Here now I have to, again, do my PEMDAS rules first. So I have to go 3 squared, which is 9. 3 times 2 is 6. So 9 times 6 is 54. This would be x, and this would be y squared. Plus, well, 3 to the third is 27. Y to the third. And there you go. Now, if this here was a negative sign instead of a positive sign, all your y's would be negative. So you can see it would not affect this first term. Let me get a different color and we'll see. Let's pretend this was negative. So it would not affect this first term because there are no y's in it. Well, here there is just one y to the 1. So it would make this actually a negative instead. This one here, this term has a y squared, so I'm going to be squaring that negative sign, so this would stay positive. But in the last one, y to the third is an odd power, so this would be negative. So you can see if this sign is negative, my signs would just switch. This term would be positive, this one would be negative, this would be positive, this would be negative. So I hope this was helpful.